Imagine sinking deeply into a plush recliner on a lazy Sunday afternoon. Your body settles into the cushions and you achieve perfect, heavy stillness. Then someone calls out your name, asking you to get up and run an errand. You know exactly how heavy your limbs suddenly feel and the sheer physical effort required to peel yourself out of that perfect resting state. Now flip the scenario. Picture yourself sprinting at top speed down a 100-meter track, pushing your body to its absolute limit. At your maximum sprint, imagine trying to come to a dead stop within a single second, or attempting to make a sharp 90-degree right turn without slowing down first. Your body simply cannot execute those immediate physical changes. You can only start moving, come to a halt, or alter your path gradually. Biological muscles and joints aren't the only things bound by this limitation. Every inanimate object experiences the exact same resistance to starting, stopping, or turning. Every physical thing in existence will stubbornly continue to do exactly what it is currently doing. If an object is resting, it wants to stay resting. If it happens to be moving, it wants to stay moving. This absolute resistance to change is the default setting of reality, which raises an interesting mystery. If everything resists change so fiercely, why does anything in the universe ever move at all? Physicists have a formal name for this universal stubbornness. We call it Newton's first law of motion. The law dictates that an object will maintain its exact state of rest, or it will maintain its exact speed and direction indefinitely. But there is a vital condition attached. This law only holds true if the external forces acting upon the object are balanced. Having balanced forces does not mean there is an absence of force. It means that all the pushing and pulling from gravity, friction, or other objects perfectly cancels out, resulting in zero physical change to the object. When forces are perfectly balanced, two scenarios exist. Case 1, the object at rest. Equal forces mean it remains stationary forever. Case 2, the object in motion. It never speeds up, slows down, or stops, maintaining constant velocity in a single direction. As long as the forces surrounding them remain perfectly equal, an object is trapped indefinitely in one of these two immutable states. If perfect balance locks reality in place, how do we ever initiate movement or bring something to a halt? The system requires a disruptor. We need an unbalanced force. Watch the stationary sphere when an unbalanced force strikes it. The unequal pressure shatters the state of rest and compels the object to move. Similarly, an unbalanced force hitting a moving object from the side breaks that constant velocity, forcing it to change direction. The unbalanced force is the only mechanism in physics capable of overcoming an object's natural resistance to change. This brings us right back to the scenarios we started with: the extreme physical effort of getting out of that recliner and the impossibility of stopping a sprint on a dime. Rising from your lazy Sunday position requires your muscles to actively generate an internal unbalanced force, one that is physically stronger than your heavy, resting state. To safely stop a top's friction between your shoes and the track, to combat your own intense constant velocity. Calculating and manipulating these precise physical imbalances is how engineers build everything from car brakes to rocket thrusters, which is exactly what we will explore in the next episode. To alter your state of motion, or the state of any single object in the universe, you must act as the unbalanced force.